Welcome back. Today we're going to be finishing Unit 2 with talking about algebraic expressions. These are expressions that have both variables and numbers, so make sure that you have your calculator, and let's go ahead and get started right now. Welcome back. Today we're going to be finishing Unit 2 of expressions by finishing up with simplifying algebraic expressions. So let's go ahead and get to it right now. So here we are at example A, and it says combine like terms. So we're going to be combining like terms, and it gives us a chart is a useful way to organize like terms. So we've drawn a chart there in our bottom left-hand corner. So let's go ahead and get started and figure out what things that we have that are alike. Well, before we want to go ahead and combine like terms, we want to remember that it's very important to don't forget the sign. Anytime that we're combining like terms, we want to make sure that we have the sign. So in my expression, I've got 3x, that's got a variable or a coefficient in front of it. I've got a constant at -8. I've got 5x, again with a coefficient, -12x, again coefficient, but same variable, and 4 as a constant. So I've got one variable, so that variable is x, and the other type of number that I have here are constants. So I'm going to put the x's on one side to combine and the constants on the other side to combine, because I cannot combine x's and constants. They're different things. X's have x's with them, or variables and coefficients together, and constants are just constants. They don't have any variables. So on the x side, I've got the 3x at the very beginning. I've got a -8. That's going to be a constant. I got plus 5x, very important to keep the sign, so I'm going to put that on the x side. -12x, I'm going to put that on the x side. And +4, that's going to end up on the constant side again. Notice I carried the sign. So now I'm going to just add, because combine is a fancy word for add. I'm going to be adding up all the things on each column, and that's going to give me my final expression. So I've got 3x plus 5x and -12x. So again, I can't put x in my calculator, but I can put all those coefficients in my calculator. So I'm going to do 3 plus 5 plus -12. And when I do that, I end up with -4. And since we're talking about x, I've got -4x. Important to keep the sign, because otherwise I would not have known that my answer is going to end up being negative. Now I'm going to add my constants together, -8 plus 4, and that's going to give me -4. If we don't remember our integer rules, it's always a good idea to use our calculator. Better to use our calculator to get the answer wrong. So all I'm going to do now is rewrite my expression as -4x minus 4. That's it. That's as simplified as I can get. I cannot combine these together and get -8x. They are not the same thing. -4x is a variable and a coefficient, and -4 is a constant. They are different things. This is the end of the problem. This is my answer. Do not attempt to add them together. I hope I am being very clear here. This is as far as you can go. This is the end of the problem. Excellent. Let's go on to example B. So here we are at example B, and it says, again, combine like terms. I've grabbed myself a fancy little chart there that has another section in it. Let's see why I have another section in my chart. So I've got 8x, I've got y, I've got -4x, +8, -7y, and -2. So the reason that I have a chart that way now is I've got 8x, that's a variable, and I've got y, that's also a variable, but they are different variables, so I cannot combine them. So I'm going to have three sections. I'm going to have a section for x, I'm going to have a section for y, and I'm going to have a section for constants. So let's go through our expression now and figure out where everything belongs. So 8x is going to be in the 8x column. Plus y is going to be plus y in the y column. -4x is going to end up in the x column. +8 is a constant. -7y in the y column. Again with the negative, don't forget the signs. And -2 again in the constant section. So now I'm going to be combining. Again, combining is a fancy term for adding. So I'm going to add, and I can use my calculator if I don't know my integer rules. 8x minus 4x is going to be +4x. Y plus -7y is going to be -6y. And +8 minus 2 is going to be +6. So again, I'm going to rewrite my expression as -4x. Oh, +4x in this particular case. Let's fix that. +4x minus 6y plus 6. Now, does it matter what order I write them in? It does. I'm going to be writing them in alphabetical order. This is called standard form. You're going to need to know it for this year as well as yours going forward. So x comes before y in the alphabet, so x gets to go first here. So 4x minus 6y plus 6. Now let's have you try some practice problems on your own. So here we are at practice problem number 1. It says combine like terms and the expressions given to you. I want you to do this one on your own. Pause the video now, do the best that you can, then press play again to see if you are right. How did you do? Were you able to get the answer correct? Did you fill in the chart the way that I did? You don't need a chart to do combine like terms, but it is a helpful tool. Hopefully you got negative 2y plus 8. And let's go ahead and move on to the second practice problem. So here we are at practice problem number 2. Again, a long expression there for you to try, and we've given you a chart. I want you to go ahead and try this problem on your own, then press play again to see if you are right. How did you do? Were you able to get the answer that we got, negative 10x minus 2y plus 8? If you didn't, go ahead and take a look at my work and see where you may have made the mistake. Go ahead and fix the problem on your paper, and let's go on to the next example. Here we are at example C, and it's talking about something called the distributive properties. So this time I've got 3 outside the parentheses of x plus 4. When I see that 3 outside the parentheses, this means that I have 3 sets of x plus 4. So when I go to combine like terms, I know I have 3 x's. I have an x, I have an x, and I have an x, because it says I have 3 sets of these, so I have 1 x for each set. Then I've got a plus 4, a plus 4, and a plus 4, because I've got 3 sets of plus 4. So to combine like terms, x plus x plus x is going to give me 3x. 4 plus 4 plus 4 is going to give me 12, so I'm going to end up with a final answer of 3x plus 12. Let's go ahead and take a look at another example. So here we are at example D again, and I've got more distributive property to do. I've got 4, and then on inside the parentheses, 2n minus 5. So that means I'm going to have 4 sets of everything that's inside the parentheses. So I'm going to have 4 2n's. So I got 2n, 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 2n. So my 4 sets of 2n. Then I've got 4 sets of negative 5. So I've got negative 5, negative 5, negative 5, and negative 5. So now I can combine my like terms. 2 plus 2 plus 2 plus 2 is going to give me 8n. And then I end up with negative 5, negative 5, negative 5, negative 5 is going to give me negative 20. So my final answer is 8n minus 20. So let's move on to another example. So here we are at example E, and again, we've got my distributive property, and I've got 12 on the outside, and in parentheses, 5n minus 8. Wait, I've got 12 sets of 5n and minus 8. There's got to be a more efficient way to do this, and there is. And that more efficient way to do it is multiplication. So multiplication is the way that's going to be much more efficient. So I'm going to be just multiplying my 12 to the number inside the parentheses. So I'm going to do 12 times 5n and 12 times negative 8. And when I do that, 12 times 5 is going to give me 60n, and 12 times negative 8 is going to give me negative 96. That's a much more efficient way than writing out 5n, 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 5n 12 times, and negative 8, negative 8, negative 8 12 times, and adding them together. So multiplication is going to be the much more efficient way to do distributive property. So let's go ahead and have you try a couple on your own. So here we've got a couple practice problems for you, number 3 and 4. I want you to try these problems on your own. Remember the more efficient way. Of course, you can write them out as sets if you'd like, but there is a more efficient way to do this. And careful when you're multiplying your signs. Use your calculator if you want. You don't have to have your integer rules memorized, but you can use that calculator. You should always use your math tools. So try these 2 problems on your own, then press play again to see if you are right. How did you do? Did you get both answers correct? Notice that when you multiplied the negative 7 and the negative 3, you ended up with a positive number. Same thing, negative 7, negative 8 gave you a positive number. So you have to make sure that you're including that sign when you're multiplying things together. So make sure your answers look like mine. If they don't, you want to go ahead and correct both of those now. But if you have, let's go on to the next example. So here in example F, things really start to get real. I've got 4 outside the parentheses, x minus 3, and I've got a 5x, and I've got a 9. I'm going to have to combine like terms and use the distributive property, because I need both in order to simplify this expression. So when I have both, I want to remember the steps. I'm first going to start with the distributive property, or distribute, and then I'm going to combine like terms, or CLT. So since I've got distributive property first, I'm going to go ahead and do that as my first step. I'm going to distribute my 4 to my x and my 4 to my -3. Before I combine like terms, I'm going to use the distributive property on anything that can be distributed. So in this case, I can distribute the 4 just to that x, just to the -3. Not to the 5x, not to the +9. They are not inside the parentheses near the 4. Only the x and the -3 that are near the parentheses or inside the parentheses near the 4 are the things I can distribute to. Do not attempt to distribute the 4 to everything. Only the things inside the parentheses next to it. So 4 times x is 4x. So bring that in. 4 times -3 is -12. So there I've used the distributive property. I'm going to bring down my 5x and I'm going to bring down my +9 so that my new expression is 4x minus 12 plus 5x plus 9. Now I can combine like terms. You can make that chart if you'd like. I think I'm okay without it, so I'm not going to, but if you want to use that chart or table, you can. 4x plus 5x is going to give me 9x. -12 plus +9 is going to give me -3. So my final answer is 9x minus 3. So remember, it's very important to do the steps and not overdo them by trying to distribute to everything. Let's go on to another example. So here in example K, I've got -2 inside the parentheses and then 3n plus 5 plus 4 inside the parentheses, 7 plus n. So here I've got two sets of parentheses. So I'm going to have to make sure that I follow my steps. I'm going to have to distribute before I can CLT or before I combine like terms. So I'm going to start by distributing the -2 to the 3n and the -2 to the 5. And then I'm going to distribute the 4 to the 7 and the 4 to the n before I combine like terms. So -2 times 3 is going to give me -6n, and -2 times +5 is going to give me -10. So that's one side of my expression. Now I'm going to distribute on the opposite side of the expression. 4 times 7 is +28, and +4 times +1n is 4n. Again, that n doesn't have a coefficient. It's all just 1 by itself, just one n there. So 4 times 1 is 4n. Now I've got an expression. I've got -6n minus 10 plus 28 plus 4n. Now again, I can combine my like terms. You can use that chart if you want. I think I'm okay. -6n plus 4n is going to give me -2n. -10 plus 28 is going to give me +18. So -2n plus 18 is my final answer. Now let's have you try a couple on your own. Here we are at practice number 5. You're going to try this one on your own. Notice we've got a couple sets of parentheses in there, and you're going to have to do both in order to get to the final simplification. So go ahead and pause the video now, try it on your own, and then press play again to see if you are right. How did you do? Did you get the final answer that we did? Hopefully you did. If not, go ahead and take a look at the work that we did in order to figure out where you may have made your mistake. But if your answer is correct, let's go on to the next practice problem. So here we are at practice problem number 6. Again, you're going to be trying this one on your own. Use that chart if you need it. If you didn't need it, that's fine. But if you need it, go ahead and write it out. Go ahead and try this problem on your own. Then pause the video. Then just play again to see if you are right. How did you do? Were you able to get the answer that we got? Notice that -15 that you create and that +15 that are there are going to cancel each other out and leave you with just x's. So you should end up with just -14x. If you wrote -14x plus 0, that's not wrong, but there's no reason to write the +0. You can just write -14x. All right, let's go on to the last example. Here we are at example G. It says 2x squared minus 3x plus x squared minus 2x plus 1. So again, we've got, let's take a look at our expression here. I've got my table set out for 3, but I only see one variable in x. However, since one of them is x squared, that cannot be combined with regular x. They are not the same thing. One is raised to a power, the other one is not. So they cannot be combined, so I'm going to have them in separate categories. I've got one category for x squared, one category for regular x, and one category for constants. So let's go through our expression and break them out now. 2x squared is going to be in the x squared column. -3x is going to be in the regular x column, not with the x squareds. Positive x squared, going to be in the x squared column. -2x in just the regular x column, and +1 is the only thing in the constants. So now I'm going to combine my like terms by adding them together. 2x squared plus 1x squared is going to give me 3x squared. Negative 3x and negative 2x are going to combine to give me negative 5x. And positive 1 doesn't have anything to combine with, so it's just going to be positive 1. So I'm going to have now a final expression of 3x squared minus 5x plus 1. And again, this is as far as I can go. I cannot combine these terms any further. This is my final answer. The x squared and the x's cannot be combined. You cannot add them all together and get 9x squared. That is not accurate. This is your final answer. Please make sure that you've gotten this written down, and then that brings us to the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.